I'm gonna give you kids a lesson about science. Follow me.
All the girls stomp your feet like this. Few times you've been around the...
Okay, kids, so the first thing that we're going to be learning about today is chemical reactions. A chemical reaction is the process in which atoms are rearranged to produce new substances. Now, can one of you guys tell me what an example of a chemical reaction may be? Brunette.
Spoiled milk.
Well, let's see. Oh man, you are right. Now, you with the purple sweater on. Why is that an example of a chemical reaction, my friend?
The properties of the substance produced in a chemical reaction are different than the properties of the original substances.
Excellent! Gold star! Moving on. So, now we're going to learn about chemical formula. A chemical formula uses chemical symbols and numbers to represent a given substance. Now, I've got some handy-dandy water here. So, what could be the chemical formula for water? Do any of you guys know?
H2O.
Frank.
This, class, is the H2O atom. A chemical equation is an expression that uses symbols to show the relationships between the starting substances and the substances that are produced by a chemical reaction. Now, can one of you Coolio teenage kids tell me an example of a chemical equation?
Well,
Raise your hand. You brunette.
C plus O2 is to CO2.
Show me the reactants, which are the substances that participate in a chemical reaction. I already called on you.
C
Pay
plus
attention.
O2.
Okay. Yeah. And you, brunette, show me the products, which are substances formed in a reaction.
CO2.
Now, both of you, point out to me the yield side. Alright. So, now we're going to move on to the law of conservation of mass, which states that matter is neither created nor destroyed in ordinary physical and chemical changes. Now, Alex, or dirty blonde girl, why don't you show me an example of a law of conservation of mass?
Cooking an egg.
Cooking an egg. Let's try that. Okay, kids, now we're going to learn about endothermic reaction, which is a chemical reaction that requires an input of energy. So, one of you guys show me an example of something. What could be endothermic reaction?
Photosynthesis.
Wow. About exothermic reactions, which is a chemical reaction in which energy is released to the surroundings. Now, what could be an example of exothermic reaction?
Burning a candle.
Okay, do you guys may have a candle, maybe?
Yes.
Only the teachers handle the fire. Safety goggles. All right. This is exothermic reaction. And why would that be, Miss Olivia?
Because it releases energy as heat and light.
Good job. Okay, kids, now it's my turn to show you an example of the law of conservation of energy, which states that energy cannot be created or destroyed. So I'm going to show you an example.
Okay. Ready, set.
That was scrumptious. Next up is temperature. Temperature is reactions usually occur faster at higher temperatures. Particles move faster at higher temperatures because the reacting particles move more quickly they are more likely to collide and react. What could be an example, I wonder? Anyone know? You.
That
What is this called?
galley thermometer.
Alright, next up is catalysts. A catalyst is a substitute that changes the rate of a chemical reaction without being used up or changed very much. Catalysts can increase reaction rate by bringing together reactants. Enzymes are a type of catalyst found in living things. So, I've got some bread here. And what organism is necessary for bread to become leavened? Leavened, you.
Yeast.
Don't you mean yeast? Surface area. The reaction rate increases when more reactant particles are exposed to one another. Crushing or grinding solids increases their surface area and the reaction rate.
All the girls stomp your feet like this. Few times you've been around the
At higher concentrations, there are more reactants in a given volume. The reactants are more likely to collide and react. The reaction rate is higher when reactant concentration is higher.